Welcome to Mostly Engineering and another part in our Enigma build series. So, welcome to this episode, and spoiler alert, the biggest failure yet, or I hope the biggest failure in the series period, because honestly, I don't want to do this again. It took a while to recover, let's put it this way, and more on this later. But the plan for today is to manufacture a rotor shaft and the shaft for our reflector drum so that we can put the rotors and the reflector into our machine for the very first time. And as you can see here, these two parts are relatively simple, relatively straightforward. The interesting part is that I'm going to machine them out of stainless, and so far I have no idea how to work with this material. I'm not even sure if my little Proxxon Lathe and the milling machine can actually handle it. And if you take the rotor shaft to make the construction a little bit easier, instead of making it as one part, we will make it as two. So we have the shaft and then this little ring over here as a separate part. Therefore, I don't have to turn down basically the whole length of the shaft down to consistently 7 millimeters. Instead, we will just have a round stock that is already consistently 7 millimeters in diameter, and we only have to turn the two shoulders, and then we manufacture the ring. And the ring we manufacture in a way that the hole for the shaft is slightly too small. Then we heat up the ring, the metal expands, the hole gets big enough for the shaft to pass through, and when the ring cools down, it will grip around the shaft as tight as can be. And for the reflector shaft, we are basically doing the same. So let's go to the lathe and see how we can handle stainless. So, and we have the stainless for our shaft put into the machine. Now the operations are very simple, just face it off, cut it to length, and then machine two shoulders on each end. But of course the interesting question is how this thing can handle stainless. So let's see. Definitely cooling. Safety glasses. So, and here we have our parts, and I have to say stainless machines are really nice, at least this type. It cuts really smooth, but you have to go quickly because this thing actually work hardens pretty severely. So on the first 4 millimeter of the shoulder where I could go quickly, it nearly cut it like butter. On the last half millimeter where I had to go slow in order to hit my mark, you really felt how this material gets harder and hard to actually cut. On the other end, heat setting the ring actually didn't work out. Main reason probably being that I couldn't find the 6.9mm drill, and a 6.8mm hole for a 7mm shaft is definitely not wide enough. Even so, I heated it up till it was glowing. It didn't expand enough for the shaft to actually fit. So what I did instead is remount the hole and then glued this ring on with some bearing glue. Maybe not as strong as the heat set solution would have been, but definitely strong enough for what this part needs to do. Very similar on the shaft for a reflector drum. Machines really nicely, also machines really nicely on the milling machine, but cutting the thread was a little bit of a problem. When you feel you're going to break the thread, you go back immediately and you don't say to yourself, a quarter turn won't hurt. I know this, and despite knowing this, I didn't do it, and here you can see the result. One ruined part and one broken tab. And yeah, it was a first pre-cutter stage, so yeah, not great. Even more not great that this of course happened Saturday evening, and I wanted to have it done by Sunday, and you are definitely not getting a replacement that quick, even if you pay for express shipping. So what I did, I drilled the hole in that the screw can barely fit, and we have a really tight fit, and then I used the screw more or less as a pin and glued everything together. Not the most elegant solution. The machinist cringes a little bit, but it looks nice. These parts are definitely not going anywhere, and it will do its job just fine. And I finished it on time, what makes the prop maker and me very, very happy. So let's put this thing into the machine and see how everything fits. So, and here we have the rotors already put in, and as you can see, there are only two, because 3 rotors actually don't fit. And yeah, that's a bummer. Reason for this is this pin plate over here shouldn't be flush with the surface. It should be recessed by about 1.6 millimeters, and in the pictures it's hard to see, and in the plans I just missed it. Yeah, and it's a current situation when you put the rotors together and push them together, you can't really push them far enough together that you can then fit the shaft in here. We are missing about 2 millimeters on this end, and if this plate would be recessed 1.6 millimeters, the pins can go in further in here, and 1.6 millimeters here, 1.6 millimeters here, 1.6 millimeters here, and you see where the 2 millimeters are coming from. To illustrate it a little bit further, here is a cross section of the rotor, how it should look like, and here's a cross section how this rotors actually look. And the problem with this is that this mistake is so deep in the basic construction of the rotor that there is no easy way to fix it. The only way to fix it is to do all 5 rotors all over again. And yeah, that's a real bummer. Of course, we can use a lot of the parts over, but all the pins, all the wiring, we have to do start there new from scratch all over again. And yeah, that's frustrating, to be honest. I'm only lucky at the moment. I'm really happy at the moment that I funded a little bit the start of the Kickstarter campaign. because yeah, I want to figure this stuff out before we start. So if you're waiting for this, I'm sorry, but probably next year. Yeah, this is the main problem. The other problem we uncovered is, as you can see, the rotors wobble. All of them wobble. This one is pretty outrageous. The other ones are, yeah, they wobble, but this is probably still within the specs. And the problem, or the reason, I think, is that when we are printing the pin plate and the central column, where these two surfaces meet is where we have all the supports, and by sanding off the supports, we are probably not 100% straight on the surfaces, and then we put it together, it's not 100% straight. We push the bushing in, and this then doesn't sit perfectly, and therefore the axis of rotation and the rest of the body parts is not really straight, and we get this wobble. Another thing is, and you can probably see it here, is that the paint actually rubs off when all the rotors are sitting under pressure and moving against each other. And the solution for both problems is we're going to reprint the parts, what we have to do anyway. And this time I'm using a black engineering resin, so if the paint rubs off, it's still black underneath. And this two different shades of black usually give for a really nice weathered look, and you don't see the gray plastic underneath. And the big advantage of the engineering resin is that we can put it on the lathe, we can put it on the mill and work on it without it shattering. And so in the future we are not going to sand off all the supports, but milling them off, and therefore ensure that the surfaces are perfectly straight and everything in here is very nice and aligned. And the last problem is that just gluing the bushings in is not enough. When we put the rotors in and push them together, we push more on one side than the other one, so these get a little bit crooked on the axis, and this means the bushing get wedged on the axis, and then the axis just pushes all the bushings out. So rather than just glue, we also need a mechanical solution here. And the solution will, in the cross section, look something like this. All we have to do now is to rebuild all the 5 rotors. On the plus side, we learned that working with stainless steel is actually really nice. And on this, it's time to end the show. I hope you enjoyed it nonetheless. If you have questions, comments, as always, let them down below, and I try to answer them as quickly and correctly as possible. Don't forget to like and subscribe, and all I have to say now is thanks for watching, and see you at the next time. Bye bye.